This is a quick review for the first quiz we had, first quiz of the second quarter. It was on conjecture, counterexample, other logic statements, writing statements. So I'm just going to go real fast through some things. You can watch the full video from, I don't even remember the date off the top of my head, but it was actually probably 2 or 3 videos, and they would have in the title all of these same topics: conjecture, counterexample, logic statements, probably, I don't know if it had anything in the title at least about valid statements, but these were those topics for that first quiz. So we started with what's called conjecture and counterexamples. So a conjecture, we said, is just, it's a conclusion based on observation. Doesn't mean it's true, but we have some kind of given information that can allow us, or something we've observed that will allow us to make some kind of a conclusion that we think might be correct based on the pattern. So that's kind of the first big word, is it's based on some pattern in a lot of situations. So in this particular case, I see that these appointments times have something in common. It's not always based on addition, sometimes it is, but in this case, it's based on adding 45 minutes. Again, not always based on addition. This particular pattern is based on addition. So my conjecture would be that the appointment times are increasing by 45 minutes. That's what the conjecture is. Now, if, again, that doesn't mean that's true, doesn't mean the next time has to add 45 minutes, but I could make a pretty good guess that the next time will add 45 minutes. So again, my observation is that they're going up by 45 minutes. So my conclusion, my conjecture is that the appointment times are increasing by 45 minutes. One example is something we covered. I'm not going to go through those. Again, similar. What's going on here? Well, like I said, we're not always adding a number. I'm not adding 1/2 every time because that doesn't work for these. But what I could say is I'm multiplying by 2. Times 2 gives me 1, times 2 gives me 2, times 2 gives me 4. So again, based on that observation, I could say, all right, I believe that we have a pattern of multiplying by 2, and then I could take a guess at the next number. So the conjecture is that we are multiplying each term by 2 to get the next term. So counterexample, I'm going to go straight to counterexamples. Yes, if I need to, I'll go to the practice. Oh, here we go. So counterexamples. A counterexample is something that proves your conjecture is false. So if you can come up with a counterexample, meaning even one situation where your conjecture is false, then you have come up with a counterexample. Basically, you've proven that your conjecture is not a true statement, not a valid conjecture. So for example, in this one, it says if n is a real, this is the conjecture, and they're asking us, can we come up with a counterexample that says, no, this is not right, this is not true, therefore it's not a valid statement, and we've come up with a counterexample to show that it's not a valid statement. So the conjecture is if n is a real number, then negative n is a negative number. So again, maybe they plugged in some numbers and they've come up with this particular conclusion. We, though, are going to say, well, wait a minute, let's see if that's right or not. Let's see if we can come up with a counterexample. So if n is -4, then negative n is +4. All right, so that doesn't match up with this. They're saying if we take some number and we take the negative version of that, or we multiply it by -1, or we make it the opposite, that's what really this means. All this means all those things. According to them, it should be a negative number. But we came up with an example of starting with a negative number, which is a real number, taking the opposite sign of that, multiplying it by -1, basically, and then we get a positive number. That is opposite of this statement. That is a counter example. We prove that this statement is not always true. It might be true sometimes, but if you can come up with even one counter example, that's all it takes, then you can say this is not a valid conjecture, not a true conjecture. It's a false conjecture. This is not always true. In order for a conjecture to be true, it has to always be true. This one is definitely not always true. So really quickly, so here is a conjecture. It's saying, okay, well, if this angle ABC is congruent to angle DBE, then angle ABC and DBE are vertical angles. So it's saying if the two angles are congruent, if they basically have the same measure, they must be vertical angles. Well, if you hopefully know this automatically, that's not always true. Vertical angles are congruent, but they're not the only kind of angles that are congruent. You can have all kinds of angles that have the same measure. You could have a triangle that has the two angles inside the triangle that are the same measure. You could just have two random angles that have the same measure. So for example, here, we have an angle here that has the same measure as this angle here. They're not vertical angles. They're not exactly opposite each other. We don't have two straight lines crossing. So that is, again, is a false conjecture, not true at all. So there's an example of counterexample. We did some problems if you want to practice the problems. Up there they are right there. They started on page 129 of the pages we tore out. Some of them were based on patterns. So you see here, what is your conjecture? It has nothing to do with numbers. Some counterexample problems. Okay, so here are some counterexample problems. There was one tricky one we went over in class. Yeah, this one right here. It says, okay, well, if you give me this equation, my conjecture is that A has to be 6. So based on you telling me this is a true equation, I look at it and I go, okay, well, if that's a true equation, 2 times 36 equals 72. Well, I know that A squared, if I want to make this 36, if I want to make A squared 36, I know 6 squared is 36. So therefore, A has to be 6. Problem with that is there is a counterexample, and it wasn't one we immediately thought of. There's only one of them, really. -6 would also work. Because if I square a negative number right here for this A squared, if I square that, then I would also get positive 36. Positive 36 times 2 equals 72. So a counterexample is -6. It is another situation where we can say 2a squared equals 72. 6 is not the only answer, therefore -6 is a counterexample, and this conjecture is false. So we'll get to the next lesson. All right, so we did statements and conditionals. We actually did not get to biconditionals. We might come back to that, but I don't know if we will not. So we said a statement is something that is either true or false. The truth value of that statement is whether or not it's true or false. So if you say, I want the truth value of a statement, you would either tell me, okay, it's true or it's false. P and Q are typically what's going to be used. So it would say P is the statement, Q is a separate statement, and oftentimes P is going to be what's called the hypothesis, and Q is going to be what's called the conclusion if you do an if-then statement. The one thing I wanted to make sure you understand, P and Q do not have to follow if and then. We could just have two statements. A lot of people thought that every statement that used P and Q had to have an if and a then in it. It does not. We can just have two statements, P and Q, or a third one, R, is what I think they use a lot. So the next thing we learned is this symbol means that we are negating the original statement of Q. It means not P, I'm sorry, of P. It means not P is the way you read it, but the word we use is negating the statement or the negation of the statement. It just means we're making the statement opposite by adding or removing the word not. A lot of you tried to completely change the statement. For example, if somebody says, I love that movie, well, the negation of that isn't that I hate that movie. The negation saying not P would be, I do not love that movie. Don't change the wording in it other than removing not or putting not in typically. That's all you're doing. So a compound statement we said was combining two statements. So we take statement P and statement Q and we combine them into one. These two symbols, the upside down V and the V, this one means and, so it would be P and Q. I'll give you an example. And this one would be or, P or Q. So we said when we find the truth value of an and statement, we evaluate each statement individually. So we say, okay, well, is P true? And then we say true or false. We say, is Q true? And then we say true or false. In order for this entire compound statement to be true, for an and statement, both of the individual statements have to be true. For an or statement, only one of them has to be true. So for example, if I say, I love peanuts and M&Ms. Well, those things would both have to be true. I would have to love peanuts and I would have to love M&Ms. Then the entire statement is true. If I say I love peanuts or M&Ms, then only one of them has to be true. If I love peanuts, then this whole statement is considered true, this compound statement. If I love just M&Ms, say that was the Q statement, well, then this is still a true statement. I love one of the two. That's fine. We're fine with that. So here's an example. Oh, one thing I said, don't evaluate the original statements. Like a lot of people were getting confused. They were reading it and saying, well, wait a minute, that figure is not a pentagon. And if you don't know, it's not. It's not. Pentagon has 5 sides. Don't evaluate the original statement. Just wait until they give you something to evaluate. Then you evaluate the statements. So for example, they want us to evaluate, they want us to find the truth value. That means is this statement true or false? P and R. They could have also written and with the upside down V. Don't forget about that. You have to understand when, oh, well, I'll let you watch the full video for more. I'm really giving you too much information. So P and R, so I evaluate each individually. P is the figure is a pentagon. Is that true? Well, no, that's not true. I actually don't need to go any farther because in order for an and statement to be true, they would both have to be true. And I've already said this first statement, P, is not true because the figure is not a pentagon. So if I've already said one statement is not true, I'm done. The entire statement is not true. I need to keep evaluating. Here we say, and this was another thing people didn't understand. They were trying to make this an if-then statement. It's not an if-then statement. If you were going to write this statement out, and I think that was something that we even had to do, if you were going to write this out, you wouldn't make it an if-then statement. You would just convert all of these symbols into words. So a not P statement, and the statement is the figure is a pentagon for P. So I would just write the figure is not a pentagon. I would change it because it's a not P statement. And then I would say and then for Q, I would just write the Q statement. This is just saying write the Q statement just as it is. So I would go up to Q, I would say, oh, okay, so the figure has 4 congruent sides. So I would say the figure is not a pentagon and the figure has 4 congruent sides. That's all you do if you're just writing the statement. A lot of people, again, were trying to do tell me if it was true or false on the quiz. And I wasn't asking if it was true or false. I just said write the statement represented by these symbols or something like that. So you just rewrite the statements, and sometimes you may have to change it to not. You include the word and or depending on the symbol. And then in this case, you just write the exact statement that Q is. Oh, and we already did the truth value of that. So that's another one. Again, if you want to go back and watch that, you can. Truth value of an or, only one of them has to be true. If I were just going to write this statement, so let's say I was just going to write this statement out in words, I would say, okay, well, P is just the statement P, so I would just write that. The angle ABC and angle CBD are complementary. Then I would write or, because that's an or statement. And then I would have to do the not statement for this. I would say segment AB is not congruent to BD. That would be all I would do to write it out. Now to find the truth value of it, you determine whether or not that statement is true or false. So these two angles are complementary. Well, they're not. Complementary means they add up to 90, so that's not true. But in an or statement, I only need one of them to be true, so I'm not done yet. I need to evaluate not are. AB is not congruent to BD. Well, AB actually is congruent. Is that the little tick mark right there? So in this case, both of these are false. That means the or statement is also false. The overall compound statement is false because neither of them were true. I have to have one of them true, even for an or. So conditional was, this was one thing that was more of a memory thing, really, sort of. This was where we get to if-then statements and conditionals. If P is true, then Q is true. That's what this reads right here. So you can read it up here also. If P is true, then Q is true. So the hypothesis is what follows the if part. The conclusion is what follows the then part. So here's an example. If it rains, then the parade will be canceled. The hypothesis is the it rains part. The conclusion is the parade will be canceled part. Now, what we learned is there are different ways to change around this logic statement or this if-then statement, conditional statement. If I want to do the converse, we said we just flip the P and the Q. We flip the hypothesis and the conclusion. So it would actually read, if Q, then P. So again, the example now would be if the parade is canceled, then it has rain. We just flip the parade is canceled and it has rain. The inverse, we said we don't flip anything around. We change both original statements to the not version. So not P, then not Q. If not P, then not Q. So again, using I know it gets confusing, but just keep going back to the example. So we didn't flip the rain part and the parade being canceled part. We didn't flip them. We just made them both the not statement. If it does not rain, then the parade will not be canceled. So that was the inverse. And then last, the contrapositive, we do all of those things. We flip the order. So Q is now first, P is second. So the parade part is first, the rain part is second, but we also make them the not versions. See this little symbol? So now it would read, if the parade is not canceled, then it does not rain. We made the parade part first, but we also made it a not statement. And we made the rain part second, and we made that a not statement. So the way I suggest you remember these, we first learned how to flip the order. That was the converse. Then we learned how to make them not statements without flipping anything. Well, alphabetically, C comes before I. So if the first thing we learned was flipping, then converse is flipping things. If the second thing we learned is just making them not statements, then I comes after C, so that's when we make things a not statement. Finally, we said, well, contrapositive is the weirdest word out of all of them. I've never even heard of that, right? So the weirdest thing we could do is to flip them and make them not statements. So that was how we said maybe we could remember contrapositive. If you have your own way to remember it, that's great. You don't have to use that, but that was kind of what we came up with in class. And then I think we just went into the problems, the practice problems from there. Bunch practice problem we did not do by conditionals. Yeah, so then go ahead and just practice. You can go back and watch the video for the practice problems, but just basically do all the ones that we just went over. And you can go back and do the examples. Since I didn't really finish all the examples, I just gave you some of the already completed examples in the lesson. And that's the review for the first quiz. The deadline is coming up fast, November 14th.